Hello everyone, and welcome to The Frame. Since around 4000 BC, when the science of metallurgy was discovered and copper began to be heated and mold casted, humans have been shaping and combining all sorts of metals and alloys to achieve incredible results. One of the most advanced processes is what's known as cold forming with no heat applied. With cold forming, metals are stressed using powerful hydraulic presses, which exert hundreds of tons of pressure. Deforming the metal's crystalline structure and compressing it into a stronger and denser piece of material. Though it may look easy enough, cold forming is actually a very complex process. Rather than apply cooling to the metal, the term only refers to the absence of heat, as metal materials are forged at near room temperature. It is extremely fast and cost-effective. It uses much less energy, and so is more environmentally friendly than the traditional hot forging. The process starts with grinding and straightening, which helps reduce imperfections in the stock steel. Depending on the type of product being manufactured, the metal will either be compressed by a series of rollers, producing cold-rolled steel sheets, or compressed using other specialized heavy machinery, resulting in rods, bars, and specialty construction materials. The equipment used in cold forming will differ based on the type of product being made and the density and strength sought by the manufacturer. Here, you see a single-action configuration with one hydraulic press applying pressure to a piece of sheeting. On the other side of the press is a stationary platform to provide resistance. In a dual-action hydraulic process like the one here, you see parts being compressed between two hydraulic pistons. Known as drawing machines, these presses can apply over 50,000 tons of pressure over an incredibly small area to induce deformation. This produces a very hard and dense finished product, typically with an impressive strength-to-weight ratio. There are also multi-stage cold forming machines, which can be used to create bolts, fasteners, and other extremely durable metal components. Due to their complexity, many of these products require multiple stages before they can be turned into the finished product. In the case of these bolts, each step in the 6-stage cold forming process adds another dimension to the shape without the need to switch machines. Cold forming has become extremely popular for a variety of purposes, especially in the construction industry. From joints and studs to floor decking and roofing, this type of material is perfect for both exposed and structural parts. In fact, it's not uncommon to see cold-formed steel used in furniture and home appliances. As the process allows for a better surface finish than what you can expect from heat treating. In some cases, entire structures can be made out of layered cold-rolled steel.
This stud.
When combined with a cold-formed steel frame, these structures are incredibly durable.
A building made out of cold-formed steel with the amount of screws and fasteners that we put on the building can withstand close to 200-mile-an-hour winds. It'd be very difficult to build a wood-structured building that could withstand 200-mile-an-hour winds. You can do it, but you're going to be putting more and more wood in and more fasteners in to get that strength.
In many industries, however, hot forming is still the preferred forging process. Among its many advantages, hot forming allows for increased accuracy, reduction of springback effect, and the creation of more complex and intricate shapes. In fact, there is also a stock product known as hot-rolled steel that has a completely separate market demand and use from the cold-rolled variety. Once steel, iron, or another metal has been heated to such a malleable form, it can be worked into almost any shape. This is integral to the production of cars, airplanes, and machine parts. Through a process called hot stamping, these materials can take on ultra-complex dimensions in a matter of seconds. Nowadays, most hot stamping is done entirely by robots. This allows for incredibly lengthy production runs, as human interference is hardly required at all. The machines lead the steel, plastic, or other required material through a series of conveyor systems, stamping and molding them into the desired shapes. The machines can even cool, stack, and store the finished product, moving it from one end of the factory to another without any need for human intervention.
Die Warmumformung bietet auch für zukünftige Entwicklungen, wie zum Beispiel die Elektromobilität, das Potenzial, mit stahlbasierten Lösungen die hohen Performance- und Leichtbauziele unserer Kunden zu erreichen.
As metal manufacturing becomes increasingly globalized, those companies that make the high-powered hydraulic press machines and stampers are in for potentially huge financial returns. A single 150-ton capacity hydraulic power press machine costs over $6,000. According to recent reports, the world's hydraulic press machine market is valued at $14.38 billion. It's also expected to grow by about 5.1% by 2027. Whether big or small, industrial or precision designed, hydraulic presses are a revolutionary new way to work with metals of all kinds. When combined with robotics and automation, they represent a vast new approach to assembly line manufacturing. That's the end of today's feature, On the Frame. Subscribe to the channel to catch us on the next video.